So, last minute chance to make a huge impact in your exam tomorrow. If there's anything we've learned from the first two papers, is that the advanced information is extremely accurate. So, doing the same thing with paper three, one of the topics on there is the product rule for counting, and this is one of those topics that doesn't get much attention in the classroom. And then when we see it in exams, we're thinking, whoa, what's the method for it? So, I'm going to go straight into this one so we can learn this method here. So, Jacob picks a 5-digit even number. So, and then it gives us all these constraints, and then it asks us how many different 5-digit numbers could he pick. So it asks us about all the possibilities. So let's write out the first digit, second, the third, the fourth, and the fifth. So we have written out our 5 potential numbers, and then let's look at all the constraints that it's given us. So we know that the first digit is a prime number, so remember we're looking at numbers between 0 and 9. So all the prime numbers could possibly be are 2, 3, 5, and 7. So that's 4 numbers. So we know we've got 4 potential possibilities for the first number. The second one, well, they've given us no constraints for the second one, so we know that there are 10 digits between 0 and 9. So that's 10 possibilities there. The third digit is odd, so between 0 and 9 it's 0. Sorry, no, 0 is not an odd number. It's 1, 3, 5, 7, and 9, so that's 5 options. And the fourth digit, we've given that it's 8, so it's only 1 option there. And the fifth, we know it has to be even, so the number must end in either 0, a 2, a 4, a 6, and an 8. So that's 5 options there. All we do now is we multiply them. So 4 times 10 times by 5 times by 1 times by 5. So 4 times 10 is 40. 40 times 5 is 200. 200 times 1 is 200. 200 times 5 is 1,000. So there are 2,000 options there. So this is an algebraic version here of this type of question. So it says there are 5 starters, 6 main courses, and X desserts in a restaurant. So straight away when we're working out a question like this, we would do the 5 starters multiplied by the 6 main courses times by the X number of desserts, and that would equal all the how many different variations we could possibly have. So Riley says there are 130, so we're going to write 130 because that's what he thinks it is, and we're trying to figure out whether he is right or not. So we do 5 times 6 is 30, times by x is 30x, and that equals 130. So x equals 130 divided by x, not divided by x, divided by 30, and that means x is 4, because 30 goes into 130, 120, yeah, that's 4 and 1/3, 10 over 30. So of course it's not an integer, and must be a whole number for this whole thing to make sense. Therefore, Riley is incorrect. And the last one here, there are 20 people in a room. Each person shakes each other person's hand once. Work out the number of handshakes that take place. So there are 20 people, and they are shaking the hands of everyone else in the room. Now, if you're one of those people, that means there are only 19 other people in the room. So it'd be 20 times 19. However, with each combination, you would possibly have a double. I'll give you an example. So let's say there's Sam and John in the room, and it's Sam's turn. So Sam is shaking John's hand and everyone else. When it comes to John's turn, at some point he's going to shake Sam's hand. So they would have already done that option. So what you got to do is you got to take your answer and you have to half it to cancel out all those doubles. So it'll be 380 divided by 2, and that will give us 190.